Hi everyone, welcome back to my YouTube channel. So today we are going to solve day 11 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 1400, construct K Palindrome Strings. Okay, so let's read the problem statement first. Given a string S, okay, and an integer K, we have to return true if you can use all the characters in S to construct K palindrome strings or false otherwise. Okay, so see this example number 1. This is string given to us, okay, and K is equal to 2. Okay, so that simply means that we have to construct two palindromic strings. Okay, and if it is possible, then return true, otherwise return false. All right, so now here see, you can construct two palindromes using all the characters in S. Okay, so some possible constructions like Anna and here ELBLE. Okay, so here, so what is palindrome first? Okay, so I hope that you guys are aware what is palindrome. Okay, so palindrome is a string that reads the same forward and backward, okay, showing symmetry with respect to its center. Okay, that's the definition of palindrome. All right, so here see this example as lead code is given and case code is 3. Okay, so we have to construct three palindromic strings in this case and it is returning false, right? And here we have to construct 4, so it is returning true. Okay, so now first let's understand the few properties of palindromic strings. Okay, so now let's pause. Okay, then after that I will explain this example to an example. Okay, so first let's suppose that we have this string given to us b a b a and c. Okay, so from this how many palindrome combinations I can form? Okay, so here first part. Okay, first part, I this complete I can make one single palindrome, right? B A C A B. Okay, so I'm just using all these characters. Okay, B A C A B. Okay, so this is nothing but this is one palindrome. Okay, so this is part 1. Okay, so now two parts can I construct two strings. Okay, two palindrome strings using this. So let's try that. So here one I can form ACA. Okay, ACA, and one I can form here BB. Okay, so I can form two parts right here, right? So we can form total 5 palindromic groupings. Okay, so this is 1, this is 2. Now let's construct a third one. So 3, so I have to split I have to construct total 3 strings. Okay, palindromic strings. So can I form that? So AA I can form one. Okay, so this is also palindromic. Okay, so here we can form BB. Okay, so this is also one palindromic string, right? BB, and we can also form this C. Okay, so here 3 parts, right? Now can we form 4? Okay, next question, can we form 4? So let's see. So we can form this AA. Okay, then A is done. Then we can form 1B. Okay, again we can form 1B. Okay, and again we can form one C. Okay, so here C A A B B C. Okay, so we are just using all these 5 characters of string. Okay, so 4. Now 5 is also possible, right? So if I just use single A, okay, then again single A, then single B here, again single B, okay, and again here single C. All right, so these are the 5 parts. Okay, so here in all these palindromes you see that in this case, first let's say in this case, so here B is occurring 2 times, A is occurring 2 times, and only the middle character is occurring odd number of times. Okay, only the middle character is occurring odd number of times. Here A is occurring 2 times and only the odd character is occurring 1 time. Okay, so this is one definition of palindrome, right? So in palindrome, if we have all the characters are in even number, okay, and only one odd character, then we can form palindrome. Okay, so this is one definition. Okay, single odd character. Okay, so I can form a palindromic string if I have all the characters in even number and only one character in odd, right? So we can form a palindromic string. Okay, this is one definition. Here also same definition, even number of characters are there, A, right, and only one odd character. Okay, we can also form a palindromic if all the characters are even, if all the characters are even. Okay, all the characters are even, all the characters are even. Okay, all the characters are even here, all the characters are even, all the characters are even. Okay, so AA, BB. Okay, then we can form palindromic. Okay, we can also form a palindromic with the single character. Okay, so we can also form a palindrome with the single character, just single character. Okay, even number of characters, single character, single character, single character. Okay, so here I have explained total 3 ways to form a palindromic. Okay, one way, if we have all the characters in even and only one odd character, and then we are simply going to place that odd character in the mid of a palindromic string. That's it, that's it. Okay, and if we have all even, then we can simply form like this, BB, AA. Okay, no issues, right? We have this string, let's say B, B, C, C. So here this is also palindromic now. With even number of characters, it is possible. Okay, and with only just one odd character, it is possible to form a palindromic string. Okay, that's the definition. All right, so this is done. Okay, so now here, from here I can see that if my string length is equal to k value, okay, if my string length is equal to k value, here it is 4 now and k is 4, so then it is possible, right? So I can simply single use this t, then I can single use this r, then I can this is just use this u, then I can just use this e. Okay, the only possible solution is to put each character in a separate string. Okay, so this is clear. Okay, this is one property that I have already explained. All right, now here see this example. Okay, so here LeetCode is given, right, and k is equal to 3. Okay, so here L is occurring just one time. Okay, and E is occurring 3 times, 1 2 3, and T is occurring just one time. Okay, and here C is occurring one time, and O is also occurring one time. Okay, so now here see how many odd characters we have here. We have this one odd character. Okay, this is also odd character. Okay, odd number of times. This is also odd number of times. This is also odd number of times. This is also odd number of times. Okay, and we now in this case we can't form total 3 palindromes. Okay, using all the characters of s, right? With just one odd character. Okay, with just one odd character, we can just place that in middle. Okay, then we have to write here even number of characters, right? Even number of characters. If we have 2 a's, so a I have to write like this, 2b's. Okay, so this is how we can form palindrome, right? All the even characters and only one odd character. Okay, so this is also, this is odd. Okay, so if I want to use this, so I have to place this in mid only, right? Like this, or this e in the mid, or here some other thing. Okay, so I have to place it like this. So this is going to form one palindrome. Okay, with the use of other even characters. Okay, here there are no even characters. Okay, so I can simply write here 3 is, that's it. Okay, that's it, that's the one way. Okay, 3 is I can form, or 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 I can't place this L here or anywhere. Okay, single L we have, I can't place it anywhere. I can't place it here, it is not a palindromic string. Okay, and it's not like I can place L and T here, then it is also not a palindromic. Okay, and I can't place L in between as well. Okay, so there is no other combination. Okay, so this is odd. Okay, frequency is odd, so using this we can form one palindromic with the only even number of characters in the u side. Okay, so there are no, so we are not going to use any. Then we are left with L. If I use L here, odd. Okay, so I have to place this in some even number of characters if we have. Okay, if we have some even number character like a here, I can write, here I can write a b b a. Okay, but it's not there, nothing. So with this we can form one palindromic. Then still we are left with 3. Okay, t c o. So same case here with, if I write e here, there are no other even character to write here, or write like this, there are no even characters, right? So this is also going to form one palindrome string. Then C, O. So it is not possible to construct 3 palindromes using all the characters of S. Okay, it is not possible. So that is why we are simply returning false. Okay, so I hope that you guys are clear first with the properties of these palindromic strings, right? All characters should be even. Okay, and except one odd character. Okay, so and we are just going to place that odd character in the middle. That's it. It is going to form all the characters are even, we are fine. It's always going to form a palindrome string. or we can split all the characters in this manner. Okay, so here if s dot length is equal to k, simply return true. Okay, and here just check if the frequency, okay, if the number of odd frequency characters, okay, in my string is greater than k, okay, is greater than k, then simply return false. Okay, I have explained that here why we are returning false. Okay, so if the frequency of number of odd characters is greater than k, then simply return false. Okay, and this is one thing. So see here, okay, so this is one thing. Okay, here we have to return true, here we have to return false with that logic. And here if you see what is the frequency of a, if I want to write here, a is, okay, let's use some other pencil. Okay, a is 1 2, okay, and n is 1 2, n is 2, all right, and then b is 1, okay, and here l is 2, and E is also 2, right? So in this case, number of odd frequency characters is just 1, okay, which is less than k. Okay, then in that case simply return true. Okay, simply return true, then it is possible now, then it is definitely possible. Okay, we can form many combinations now. Okay, so here b is odd now, so b here I have to keep it somewhere in between. Okay, a, and then after that these are pending n, l, e. Okay, so I can use n here, l here, l here, e here, e here. This is one combination. Okay, ABA. Okay, so these are just some possible construction. Okay, so this is also one possible construction. That's it. Okay, so these are the simple things that we should know, okay, about this problem, and we will be able to solve this problem now. It's very easy, right? So I'm going to do write the same thing. Okay, so here constant size is 10 to the 5, and s consists of lowercase English letter, total 26 characters. Okay, so let's write the code. It's very easy, very easy. Okay, so here first of all let's calculate the length of the string. Okay, s dot length, all right, and here if, okay, and here one more thing, if let's suppose string length is 4 here, right, string length is 4, and here k value is 10 given to me, then it is definitely not possible to find the answer. 10, how can I form 10 palindromic strings using just 4 characters? Not possible. So one base condition here, if n is less than k, simply return false. Okay, simple return false. Okay, here only, that's it. Okay, now create a frequency array, okay, of size 26. Okay, new int 26, all right, and now just iterate over all the characters in my string. Okay, so s2 char array, all right, and here what we are going to do, we are just going to increment the frequency. Okay, frequency c minus a plus plus. Okay, so if my character is a, so a minus a, so at a frequency of 0 index I will just increment the frequency. Okay, so you guys already know why we are writing this. Okay, so this is done, all right. So now we have to just count the odd number of frequencies that we have. Okay, so int create one variable odd count and set it to 0 initially, and then just iterate over all the frequencies that I have. Int I is equal to 0, I is less than 26, I plus plus, and here inside this just one simple if condition, if frequency of this character, okay, this index frequency at this index, if I divide it with 2 and I didn't get the answer as 0, okay, then in that case simply means that we have odd number. Okay, so we have to increment the odd count plus plus. Okay, all right, and here I will just check here only. Okay, inside this uh, if my odd count, okay, if my odd count it becomes greater than k, then it is not possible to find just these many palindrome strings. Okay, so simply return false. Okay, so I have already explained this why this is happening. Okay, so here it is happening in example number 2. All right, so this is done, and in the else bar, okay, once this is done for loop. Okay, and in the end just return true. Okay, if here we didn't return false and here we didn't return false, then definitely we can form a palindrome string. That's it, return true. Okay, So this is where my for loop ends, and yeah, that's it. Let's run it and see if the code issues. Okay, all the test cases has been accepted. Okay, now let's submit it. All right, so see, our solution is accepted. And what is going to be time complexity for this one? It is going to be the length of the string. Okay, so here see, we are iterating over the length of string, right? Over iterating over all the characters in the string, and here 26. Okay, so you can say n plus 26 and simply n. Okay, so this is approach one to solve this problem. Okay, so here what we are doing in this approach, we are counting the frequency. Okay, we are counting the frequencies. Okay, we are maintaining the count of all the number, all the characters. Okay, a is occurring one time, n is occurring two time, a is occurring two time, n is occurring two time, b is occurring one time, e is occurring two time, l is occurring two time. This is what we are maintaining here. Can I simply maintain whether this character is occurring odd number of time, even number of time, instead of counting the total number of the characters in that particular string? Can I simply write a code so that I will get to know that this character is just occurring odd number of time or even number of time? Okay, so how we are going to do that? So there is one better approach, okay, to do that, that is using bit manipulation. Okay, so how we are going to solve this problem then? So here, first of all, some XOR operation. Okay, so you should know about the XOR operations. Okay, so this is approach 2. Okay, so if you guys don't want to solve this problem using approach 2 and you are good with approach 1, then you can skip this video. Okay, and but if you want to know this approach as well, then please go ahead, because this approach is also very important. Okay, bit manipulation, how XOR is working. Okay, so many of your doubts will get cleared here. Okay, so first of all, XOR table. Okay, so if any 2-bit value is 0, okay, then it is always going to return 0. Okay, 1 1, it is going to return 0. And if 1 is 0 and 1 is 1, then it is going to give output as 1. Okay, if it is 1, here it is 0 and it is going to return 1. Okay, so this is nothing but my XOR table. So this is, let's say, a, this is b, and this is my result. Okay, so this is nothing but my XOR table. Okay, so if 2 bits 0, then answer will remain 0. Okay, 2 bits 1, answer will remain 0. If 1 is 0 and 1 is 1, then 1 is 1, 1 is 0, 1. Okay, so this is XOR table. Okay, so now how we are going to maintain the count? Okay, so this is next, how we are going to maintain the count. Okay, so here, let's suppose uh, we have this a. Okay, then we have this a, then we have this a. Okay, this is my string, let's say. So now I want to check if the frequency of this a, if this character is occurring odd number of times or even number of times. This what I want to see. Okay, so first of all, what I'm going to do here, I will find. Okay, so this is character a. So from this particular character, okay, let's say this is my character. Okay, from this I will just subtract a. Okay, from any character. Okay, right now I'm here, so from this I'm going to subtract this. And what is the value that I'm going to get here? I'm going to get 0. Okay, because this character is a itself, right? So a minus a, from any character I'm going to subtract a. Okay, so I will get 0 here. Okay, so this is what we are doing here, right? Frequencies, so we are just finding the index. Okay, so here 0. Okay, this is what I found here. Okay, now I am just going to do the left shift on 1 0 number of times. Okay, left shift on 1 0 number of times. Okay, this is 0. So initially, let's say my this is like this. Okay, 1 is like this, so I have to shift 1 0 number of times, so it will remain it as it is, right? There's no going to be, there's not going to be any change. Okay, so once this is done, okay, once this is done, then initially I'm going to take my odd count value to be 0. Okay, so like this, 0 0 0, everything is 0. Okay, now I'm just going to do the XOR. Okay, going to do the XOR of this one. Okay, this value with the odd count. Okay, so here this is 0 0 0 0 0, and I'm going to do the XOR. Okay, so now here what it will say, I will get here 0 0 0 0, and here 1 is 1 1 is 0. Okay, one different, so here I will write up 1. Okay, so now what it is saying, what is it is saying, so here if I just check the number of set bit counts. Okay, number of set bit count, so only one is set. Okay, so that simply means that the current frequency of A is odd. Current frequency of A, this just particular A is odd. Okay, this is one time. All right, done. Now we iterate over next character. Okay, next character is also A, so here I will write A again. So A minus A, I will get 0. Okay, and again here, now instead of doing okay, first of all, 1 shifting 0 times, so here it is going to be like this only, 0 0 0 0 1. Okay, 1 shifting 0, so here I will get this. Okay, so now I have to do the XOR of this one. Okay, 1 XOR, okay, this is what I did. So I will get 0 0 0 0 0 0 1. Okay, I'm not shifting 1 anywhere. Okay, so now again I have to do XOR with, what was this? This was nothing but odd bit count. Okay, initially odd bit count, odd bit count. Okay, so now after this, if I did the XOR of this one with this one, this was my new odd bit count. Okay, so now here I have to write new odd bit count, which I got here. Okay, so here I have to write this 0 0 0 0 0 0 0 1. Okay, so what is the result that I'm going to get? I'm going to get 0 only. Okay, 0 only, right? So 0 only I'm getting. So now we have two characters, and here it is giving me total 0. Okay, number of set bits is 0. Okay, in this case number of set bits 0. So here that simply means that in this complete string until here the frequency of A is even. Okay, then same way again we move here and we will get only 1. Okay, so that simply means that the frequency of this that we will get that number of odd counts is 1 only. Okay, so only 1 bit is set. Okay, so this is what we need to do actually in this problem. Okay, so I hope that you guys are clear with this XOR operations. Okay, so now let me do one thing. Let me take this example, okay, for better understanding what we are going to do. Okay, so let me just copy this here. Okay, enable. Okay, so now here, first of all, this character. Okay, first of all, this character. So this character is A. Okay, so now we have to do this character minus A. Okay, from this character I have to subtract A, so I will get A minus A I have to do. Okay, so I will get 0. Then here what I have to do, I have to left shift the 1. Okay, left shift the 1 with this 0 number of times. Okay, 1 0. So I will get what I will get, I will get 1 only. Okay, 0 0 0 0 1 1 only, right? That simply means 1. Okay, and initially what is my odd count? Okay, odd count here, if I want to write odd count in binary form. Okay, in binary form, odd count is just now. Okay, odd count in binary form. Okay, so here 0 0 0 0, it was initially 0 0 0 0, right? In that, if I do the XOR with 1, I will get what? 0 0 0 0 0 1. Okay, this is what I was getting. Okay, XOR, and I will get this. Okay, so odd count. Now what we did, we just toggle the bit 0. Okay, so that's it. So now after that, uh, here we just toggle the bit 0. Okay, so now after that, next character is N. Okay, N. So here N I will write, so N minus A I will do. Okay, so now here N, where is N occurring? Okay, so here alphabet series. Okay, right, A B C D E F G H I J K L M N. Okay, so much maths. Okay, so here 5 10 11 12 13 14. Okay, 14. So 14. Okay, at 14 we have this N, right? Or okay, one second. Here A is occurring, we are taking A at 0 now. We are taking A at 0 index, B at 1 index. Okay, C at 2 index, D at 3 index, E at 4 index, 5 index, 6 index, 7 index, 8 index, 9 index, 10 index, 11 index, 12 index, 13 index. Okay, so 13. At 13 we have N. Okay, so 13 minus we will get 0. Okay, A is at 0, so N is 13. 13 minus 0, so 13 only. Okay, so we are just going to now left shift what? We have to left shift the 1 13. Okay, 1 here 13. So 13 means that here what we will get, we will get something like this. Okay, 0 0 0 3 4 5 6 7 8 9 10 11, 12, 13. Okay, something like this. Okay, now then I have to do the XOR of this one with this one. So I will get what? So I will get just same. Okay, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and here I have to do the XOR with this odd bit count now. So here it is 1. So here it will become like this. Okay, 1, 0, 0, 0, 1. Alright, so here what I am doing, well, I'm doing toggle bit 13. Okay, toggle bit 13. Then again next character is n. So here again n minus a I will do. Okay, so I will get 13 here. Okay, that simply means that this same value. Okay, so here I'm going to write uh, 1 second, this same value. Okay, so this same value I'm going to write. Okay, this same value here. And okay, then after that, if I'm doing the XOR of these two, so here this will again change back to 0, right? This is 1. Okay, and I'm doing the XOR of this. So 1, 1 is 0. So 1, 1 here 0. Okay, so this will again reset to 0 only. Okay, so here it but we will get 0, 0, 0, 0, 0, 0, everything 0, 0, 0, and in the end there will be 1, 1. Okay, so until here what is clear? Okay, until here if you see, so we have just one node frequency. Okay, number of set bit counts here, set bits is just one. That simply means that we have just one node number. Okay, that's the simple meaning. Okay, same way when we move to this a, then everything will go back to 0. Okay, a minus a 0. So here simply means that one left shift by 0 times. So here this will also become 0. Okay, then we have b. So b minus a, if I do, so I will get just 1. Okay, then we have to left shift 1 how many times? One time. Okay, one time. Okay, so here I will get something like 0, 0, 0, 1, 0. Okay, this is what I'm going to get, right? And here this will also if I do the XOR of 0 and this 1, 0, all values are 0 here, right? This one with this one, so I will get something like this one, 0, 0, 0, 1, 0. Okay, something like this. All right, then after that we have e. Okay, so e is nothing but uh, e minus a. Okay, so e is at here see a b c d e is at 4. Okay, so 4 minus 0, 4. Okay, 4 I will get. So here 0, 0, 0, 0, 0, 1, 0, 0, 0. Okay, so this is what I'm going to get when I'm going to do the XOR of this one. What we will get, we will get here 1, 0, 1, 0. Okay, all values are 0, 0, 0, 0. Okay, something like that, right? And then what we have, then we have L. Okay, so L is at here f g h i j k l. Okay, here so 4 5 6 7 8 9 10 11. Okay, 11. So L is at 11. Okay, 11 minus 0, so I will get 11 only. And here we have to left shift 1 11 time. Okay, then definitely here 0 1 0 1. Okay, 1 2 3 4 5 6 7 8 9 10. So we will get something like that. Okay, something like this. Okay, so 1 and this one. Okay, again we have L. So at that time this same thing. Okay, but here this is going to become 0. Okay, next time, so here it is 1. So next time again L is occurring now. So again 11. Okay, 1 11 time. So when I'm doing the XOR of this one, so this is going to reset to 0. Okay, 0 0 0 0 0 1 0 1 0. Okay, in the end, then we have E. So when we have E here, so e minus 0 4. So 1 left shift 4 times. So here 1 0 0 0 0 0 0 0 0. So when I'm doing the XOR, so in the end we will get something like this, 0 0 0 1 0. Okay, something like this. Now once this is done, okay, so after processing all the characters, the final value of or count in binary form, it is nothing but 2 now. Okay, in binary form it is nothing but 2, but this is not what we want. So number of set bit counts, is 1. So that simply means that we have just one odd character here. So which is odd character? This b is the odd character. Okay, because all other are making each other 0. Okay, all other are making each other 0. Okay, so because 0 0 is always 0, 1 1 is always 0, only the different character is going to form set a bit. Okay, is only going to form set a bit. Okay, that is simple meaning. So we are just going to count the number of set bits here. Okay, that is going to give me the number of odd characters. Okay, so that's a simple use of this. Okay, so we spent a lot of time, right? I thought I will cover it in 5 minutes. So okay, no issues. So no, let's write the code. Code is very small. Okay, so we are just going to remove some extra lines. Okay, so here if n is less than k, return false. Okay, and here one more thing we can simply write. Okay, so we didn't write it here, but here we can write now. So if my n is equal to k, then also we can get the answer now. Okay, then simply return true if n is equal to k, right? Because we can split all the characters in one right manner. Okay, this is done. Then this step is not required now. Okay, so int word count is 0, then we have to just iterate over all the characters. Okay, so here let me just remove this, so this ends here. Okay, so yeah, so now just one loop I'm going to write. We are just going to update the bit mask for each character in the string. Okay, so for character c in s2 char array, all right, and here what you need to do, here you have to write odd count. Okay, so what we are doing every time, first of all, we are finding this c. Okay, this c minus a. Okay, every time this is what we are finding, right? And then after finding this, what we were doing, we are just doing this left shift. Okay, this is what we were doing right here. Where is that table that I do here? Okay, this, then this left shift with this value. Okay, this is what we are doing. Okay, so here I have written like this, and then we are just going to do the whatever we will get, we will just do the value or XOR with that odd count. Okay, previous value of odd count, and then do the XOR. Okay, so here odd count is equal to XOR is equal to odd count is equal to odd count XOR this value that we are going to get here. Okay, that's a simple thing. And in the end we have to just return if the number of odd frequencies is less than or equal to k. Okay, so here what I'm going to do, return, okay, integer dot bit count. Okay, and here odd count. Okay, so odd count we will calculate. Okay, in odd count we just calculate the set bits. Okay, so here if this is less than equal to k, okay, if this is less than equal to k, then we will simply get the result now. Okay, then we will simply get the result, right? If this condition is going to give me a true, right? If integer dot bit count odd count is less than equal to k, is less than equal to k, then simply means that we are simply going to return true. Okay, otherwise we have to return false, right? Let's run it and see if the code issues. All the test case has been accepted. Now let's submit it. Okay, so easy. So here also time compressed is going to be often, right? So I hope that you guys are able to answer today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.